Go.
Hello!
Hello, Eric. Hello, Ryan. How are you today? Good?
Good.
Good. Okay, so remember we talked about the square root, right? Square root? Yeah? Like square root 25. What is the answer?
5.
Right, we're done. Okay, so today and previously we talked about using the binary search to compute the root the root, yeah? Do you still remember? Yeah? For example, like 25, we choose the left equals 0 and right equals 25. And then we calculate the middle, yeah? Yeah? And we compare the middle square. We compare the mid square to 25, and then depending on which side it is, we continue search in the half space, right? Yes? Until we have this reasonably closed solution, right? Do you get it? Yes? Okay. So today we talk about another solutions to compute it, recursively to compute it. How can we do it? Look, Eric. So let's say we want to compute the square root of n, right? Alright, can you see that please? We want to compute the square root of number n. And then, if I set n is equals to a squared plus b, where a squared is bigger than b, right? So for example, like I want to calculate 150. What's the square root of 150? So it equals to which number square itself is less than 150 but the biggest? 10, 11, 12, 13, 12. Yes, exactly. So 12 square plus b, right? Yeah. So 12 square plus 6, right? Got it? Yes? Yes? Okay? Okay, so remember, A is 12, B is 6, okay? So do you get it?
A is twice as big as B.
Yeah, so we try, we guess the biggest square number that is less than the target, right? So let's see. N equals n equals a squared plus b. Okay, so what can we do? Is n minus a squared equals b, right? Yes?
Yeah.
So do you still remember this formula, Eric? Like a plus b times a minus b. What does it equal?
It equals.
What does it equal? A squared minus b squared. Okay?
Yeah.
A plus b. Like 2 plus 1 times 2 minus 1 equals 2 squared minus 1 squared equals 3. Right? 3 times 1 is 3. Got it? Yes? Yes? Okay? Okay. So, okay, let me give you another example. Okay, 5 plus 3 times 5 minus 3 equals what?
5 square minus 3 square.
Equals 16.
16!
Okay, look. 5 plus 3. Hey. 5 minus 3, 2. 16. Yeah? You got it? Okay? Yeah? It's magic, yeah?
Why you're missing the times?
Okay, that's okay. Times. Okay? Now look. So look, what's this?
N
Is
minus A.
Square root of n plus a times square minus n a, right? Do you get it? Because look, this square is n, right? Yeah? And then a square, right? Do you get it? Okay? Yeah? So this will be n a square, right? Okay? So look, so this is that. So what can we get? Alright, look, what can we get? So b, if we move this thing, move this thing, okay? Move these things to the right, it will be b divided by square root plus n, a, right? And then that will be equals to this one, right? Look. And then what happens if I move the a to the right hand side? So that will be plus a, right? Yeah? Alright?
Yeah.
Look, this is the thing we want to compute, yeah? Square root of n, yeah? And this is the square root of n we are going to compute. So look, let me write again. Square root of n equals a plus b, a plus square root of n. So what happened? Look, this is the magic. Yeah. What happened if I replace this bit with this bit? Do you see this? Okay, look. Square root of n equals a plus b divided by a plus square root of n. Okay, what's square root of n? It's this one, yeah? So if I remove this, and then I replace this, the whole thing, b divided by a plus square root of n, right? A plus that. So that would be 2a, yeah? Alright?
2 times a.
Yeah? Yeah? Alright? This will be the same. So it will be b, a plus b divided by 2a plus b divided by 2a plus b divided by 2a plus b divided by 2a. So it continues that way. Do you see the magic? Okay, look. This. Originally is this, okay? Because look, square root of n, we want to calculate this square root of n, right? And then it has square root of n in the right hand side, right? Yeah? So if I remove this, and I take this whole thing, what's n? What's square root of n equals a plus square root of n? So that will be b a plus square root of n, and then plus a, right? A plus that, yeah? And then look, a plus a, that will be 2a. Okay? So you can continue replacing this square root of n. And then you come to this way. So square root of n equals a plus b divided by 2a plus b divided by 2a plus b divided by 2a. This way, continue. Right?
Yeah.
Okay? So we can do this. So by a, we know this a, and b, we know this a. B, the square root of n is just the calculation of b and a. Right? Alright? Alright? Are you still with me?
Yeah.
Okay.
A
So,
add b divided by
so look, let me
2a.
look. So square root of n equals b a plus b divided by 2a plus b divided by 2a plus b. Okay. Divided.
It's going to take that
Continue.
one over.
Continue. So it's like that. Yeah. 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 So look, let's do this. Define. Let's call it square root. Okay, square root. And we call it. We want to calculate n, but we need to use the a. Yeah. And let's define a small error. Small error. So if you want to compare two numbers, if they're the same, you can. If two floating numbers, like if you want to compute the two floating numbers if they are the same, I mean they are very close, you can use the ABS. Do you still remember? ABS, A minus B, if it's smaller or equal a very small number like 0.0001, then we can say A and B are equal, right? Because in computer, you cannot, because of computer, the way how computer represent the floating numbers, the best way to compare the equality is to use the ABS. Do you still remember your ABS? ABS, look, in mathematics, you can do this. ABS minus 3 equals what? It's the distance between the value and the 0.
3.
A equals what?
8.
Yeah, so basically ABS is, you can say ABS is x if x is bigger or equal to 0, or minus x if x is smaller than 0. Okay? Yes? This is called a function. ABS. Okay? So we use the ABS to compare these two numbers, if they are floating numbers like 0.5, 2.5. If they are difference, yeah? If the distance between them is smaller than a number, we can say it's equal, right? Okay, so now we can call this EPS error here. We put an E column, okay? Yeah?
Come.
E we can do, by default value, we can say 1E minus 5. What does it mean, 1E minus 5? Scientific number. This is the way in computer we represent 1E minus 5 is like 0.00001. Okay? So 5 actually, 1, 2, 3, 4, another 5. So 5 zeros. Yeah? Okay? So that's the small number is the same. And 1E minus
Got
2.
column.
1e minus 2 is what? 0.001. Okay? Yeah?
Got column.
Yes. Okay, so B. What's B? B equals what? We want to calculate B. N equals A squared plus B. So what's B?
Equals
N
minus A square.
A times A, okay? Or A squared. Square you can use double star. Okay? Yeah?
Yeah.
So we have N, A, we have a B. Okay? Yeah?
Mhm.
So look, now we want to calculate x, right? So x will be equals. That's why x is the number we want to calculate, right? Is that, yeah? X equals A plus B divided by, let's do it divided by A, okay? Yeah? It's 2A, but actually I'll show you why we should put an A here. So look, y, ABS, x times x, yeah? X times x, minus, which number we're comparing? We want to find the distance between the value, the target value, and n.
N.
If it's bigger than e, right? If the number, if the target is not close enough, right? Yes?
Yeah.
Then what should we do? And you can imagine, what should I return here? Return what? I want to do something here, but you tell me what should I return there? What should I return there?
X.
Return x, yes. Yeah, because this x is the target. Okay, so now, we need to. So we need to replace this bit. Okay, so let's say t will be equals x. Okay, let's save this value, and then what? And when we need to calculate this this new value of the t value. Yeah. So what does it equal? What does it equal?
It equals
So x. So this now x will be
equals
to what? A
plus B.
plus b divided by
T.
t, right?
What's T? Oh yeah, X.
And t will be what? You guess. So
A
why?
plus B divided by X.
No, actually there's a problem with that.
Why?
Is that look, this t is x, so x is that. It's actually 1a. This is 1a. Actually, we want another a plus t, right? So look, because look, this a will be a and then plus a, right? So plus a plus that. And this thing is the new, look, a plus b divided by a plus b divided by 2a. I split into a plus a, right? So why are we doing this? A plus b divided by a plus t. So this t thing is this new iteration, yeah? So it will be t, and then I need to substitute it with what?
X.
Where down? So look, x. So t equals x. Look, t. The first iteration is t equals x, right? Right? Because this is the value we guess, but it's not close enough. But we plug it into this, then it will be a. Look, the first iteration will be a plus a. That will be 2a, right? Yes. Look, it's 2a, right? So is that enough?
So,
Is that enough? Yes, I think so. Yes. Yes, I think so. So look, this is the way we iterative to computer, but a computer compute the square root based on this equation, right? Yeah. Okay. Okay. So now,
that chair is smelly.
and in order to calculate this square root of 150, you need to pass the value of a as well, right? How do we calculate the a value a? The integer part. I mean, it's
We
just int. A
We
will
just
be
square it, and if it's smaller than X.
So it will be
No,
just
I
the
mean-
integer part of it. So this is the way to show how you calculate it, but in practical it's not fast enough, because if you want to get the value of a, you need to call this square root function. And if you want to use this square root function, why would you do this? Because it's way slower, right? But this is the way to calculate this. How do you call this kind of fraction? Consecutive fraction, right? Yeah, consecutive fraction. Yeah. Do you understand this consecutive function? It's like, let's try this. Okay, a is 12, b is 6. Yeah. So square root of 150 equals what? 12
Square.
plus 6 divided by 24 plus 6 divided by 24, right? Yeah? And you can keep doing that. Okay,
You can't divide it by 24.
let's do this bit, okay? Let's do this bit. So 12 plus 6 divided by 24 plus, this is a quarter, yeah? A quarter, alright? So what's this?
And 6.
4, 96 plus 1, right?
Quarter
And
of
6,
four-
okay?
Quarter of 24 is.
So it's, I
No.
put it that way, so that will be 97, 24 plus 12, right? Yeah? So what's this number? Let's try. Let's do this, okay?
24 divided by 97.
Okay, 24 divided by 97, what does it equal?
I guess.
Look, that's a 0, yeah? So that's 0.2, right? Yeah, it can't be 3, yeah? 2, 4, 1, 9, yeah? 6, 4, and then what? 5? No, 4, 38, 4, 2, and then 7. And what? Let's see. So we have a very close number. It's 12.24. Okay? Yeah.
Yeah.
So let's square this number. Okay. Let's use computer to square it. Let's see what does it equal. Okay. Okay. So let's see. Square.
They can't see it.
That's okay. Square 12.24 square 2. So it's 149.8, right? 149.8. So look, it's very close to 150, right? Yeah? So do you see how we approach this? If we keep doing this,
I need to point
Look,
to left.
look, if we keep doing this, if we say 150 square equals 12 plus 6 divided by 24 plus 6 divided by 24 plus 6 divided by 24. Yeah, if we keep doing this, then we'll
6
get a...
divided by 24, not 12.
Yeah. So do you get it? Yeah? Yeah? What do you call this? Continuous fraction, right?
Hey, whatever.
Okay, so can you tell me what's one thing you learned from today?
About continuous fraction.
Yeah?
That's
Okay, so one is missing here. Can you tell me what is that?
Return X.
Return x. Return x. Return x, yes? Yes?
Yeah.
Okay, so how about this? I divided it. Okay, can you write it down? What's b?
B
What's b? What's b?
equals N
b equals what?
minus A square.
A squared. A times a, yeah? A times a. A times a. A times a. You can write it as a times 2. Yeah? Alright?
Yeah.
Another way of doing it, you can use the power function. Power a2. These three things, the same. A times a. A times 2. Yeah? Or power a2. Power function is a squared. Okay?
Yeah.
Okay, so today, good job today. Good job.
Bye.
Okay? You need to say thank you and see you tomorrow.
Bye and see you tomorrow.
Okay, bye bye.